Welcome back. You have a good break? A little bit nuts, a bit of Coca-Cola, etc. Next to me, Tiago de Varia.
Wow.
Nice name. From Brazil?
Really, yes.
Yeah, cool. And you're working here at the corner, around the corner?
Yeah, Linked headquarters is right around in the Meern, so really close to here.
Okay, cool. We talked about pain mitigation.
Oh.
Can you tell me something about that?
Yeah, it's because working as a solutions engineer into companies, sometimes I get there and they already have the solution in mind and they just want to hire the expertise. But sometimes I prefer to look at the real pain before proposing a solution, so we go through a discovery phase together with them instead of just, I want to migrate to AWS or something like that. We usually, why do you want to do this? What are the problems that you're facing here? And try to find the real pain and how we can mitigate that.
Cool. With more value.
Yep.
Okay, cool. And you're talking about, right now, about machine learning.
Yeah.
Cool subject.
Yeah, everybody thinks AI is the buzzword and the silver bullet, so I'm going to crash a little bit of someone's dreams here, I think.
Okay, are you ready for that? Okay, good luck.
Thanks. Well, welcome everyone. I know that a lot of you could not endure the entire day of conference, that's why I have a big room now. But I'm here to talk about AI with a DevOps mindset. And on that case, I need to give a little bit of context onto that. First, talking about Linked. Yeah, they pay my salary, I work for them. It's a great company to be because it is really famous in the Netherlands for the part on the top, the sourcing. So a lot of companies, when they need someone specifically of some requirements, like I need a Java developer that knows Polymer, they reach out to Linked, and Linked is quite fast in providing them CVs for those people. But what I do there at Linked is more the solutions engineering part, and that is related to the pain thing that we just mentioned. Trying to identify the pain and how we can bring value with IT solutions for companies. And we use the sourcing part as our superpower. If we need someone really specialized in something that we don't have at that project, we can probably find someone from you really fast that can help you in a short period. And we also give a lot of training for some companies around in the Netherlands. And our trainings are very custom built for what they actually need. So to give a little bit more context about me, what I like to do is playing with my daughter, playing the guitar, playing the piano, cooking, and of course eating, as you can see. But I started doing pure math back in school, and I did my master in machine learning and AI 11 years ago, and deep learning was not a thing. And I noticed that majority of my time I was spending doing SQL queries, looking into databases, so I started to go more and more into the software engineering part. And I work in some open source projects in the sharding databases, creating algorithms and things. I did network administration, I did system administration, and I started working with AWS 9 years ago, so I have quite some time doing it. So I always worked with open source projects, very fond of it. I worked a lot with Python, with the cloud, and I always put the cloud with the rain because it's not just rainbows as people expect. When people tell me we're going to the cloud because it's going to be cheaper, I usually laugh at them, but I try not to. I use a lot of Go and Kubernetes recently, TensorFlow, Kubeflow indeed, and I use a lot of Scala and Spark. I also organize some conferences like Amsterdam AI. I did the DevOps Days Amsterdam for some time, IT Next, and I like to give training a lot for people because my trainings are really straightforward at some point because I usually just give an exercise and let people crush their heads against it. So I don't have to prepare a lot of slides. As I said, I'm the head of solutions engineering at Linked, and when I go into clients, usually it's because someone knows someone at Linked and they, hey, Tiago, come here, and they usually start with something similar like this. And I start to realize how AI is this silver bullet buzzword that people keep asking about. It's a little bit like how big data was 6 years ago, a little bit how agile is pushed into every word, even if it's not agile. AI is also in that case. And sometimes on these meetings, someone also pops up and tells this to me. And then I start to realize that, again, everything is a buzzword. But then comes the ultimate Medium reader, the person that reads all the Medium articles and talks about everything, but it's a Microsoft Visual specialist kind of like. And they come usually with this. And when I see things like this, of course this is an exaggeration, I hope, but it's maybe like a buzzword bingo kind of things. This person will probably get funded if he does this. We move to the Bay Area, have his own startup and start playing around with this stuff. Because this is what is happening now. AI is this magical thing that will solve all the problems. Just put your data here and AI will add value. And that's not what actually happens, especially because to give some context around what DevOps is and what it means, who here knows or read the DevOps handbook? No one, nice. One person, good. In the DevOps handbook, there is a description about what is called the downward spiral. And to give you some context of what it is, who here is a developer or engineer or something like that? Who here is an IT manager? Who here is a PO? One person. Tell me if this is similar to what you have seen. You have a client, you are building some software or something, you decide that you're going to sell a feature for that client. I'm going to add this, you're going to pay this extra thing. I'm going to deliver this feature by the end of the quarter. Your IT team, your developers, they start looking into that. And they found that the new React version has everything that they need, and they saw that in a presentation, and it's amazing, it's going to solve all the problems. And they start playing around with a new stack that involves a lot of refactoring, because they want to use that. And they start cutting corners, and when it comes to bring that into production, the operations team, especially back in the days, would be like, whoa, 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 whoa. We never tested this in production. What about CISO? Have you talked with CISO? What about the security framework? What about this? What about that? And they start blocking things. Because it's from nature of this, because who gets called in the middle of the night if something goes wrong? The operations guy. So he starts to like reframe this. And on the other sense, the development team wants to move forward and wants to do stuff because that's cool. Majority of the developers want to build cool stuff with new technology. So on the other side, you want someone trying to move faster, and the other one really, really afraid that things will break, and they don't meet their target, things start to collapse, and then the PO, together with the sales team, have to go to the client and like, okay, we didn't do it, but next quarter we will do that, and even more. To keep the client happy, and they take the whip out, they start whipping the developers like, hey, we need to make this happen, we need to make this happen. And the developers have to like start cutting corners around and put that into production, even though it's not safe, and start breaking stuff. And the operations team gets upset because they were not involved. And you start going into this spiral of like cutting corners around things. And then what usually happens is everybody is unhappy, the client as well, and the developers and the operations people decide to leave the company and promise that this is not going to happen again. They join another company and it happens again and again. And this is what the DevOps movement tried to come to break. It was the culture. It was not bringing development and operations together. It's a culture change that needs to happen. And this is why it came, like to fight this downward spiral. It came to try to do this, bring product and development together with IT ops, with quality assurance, with InfoSec at first. How to bridge this gap. And one of the solutions that was found of this, it was like making the flow go faster from idea into production, involved with the tooling of CI/CD, involved with sharing knowledge, observing, making this loop smaller, similar things that are more involved to culture change than the tooling on itself. And what about AI? What AI has to do with this? AI definitions are insane now. Nobody knows how to define. There is no definition, and that's good and that's bad. This is my definition. It's wrong, it's right, it's whatever you want to call it. This is my definition, and I want to just to point it out that when I'm talking about AI from now onwards, this is what I think AI is. Make computers capable of doing things that, when done by a human, would be thought to require intelligence. Intelligence or automatization. For example, tagging someone in a picture. You can ask your friend to tag someone in a picture, But you expect that if he does that 1 million times, sometimes he will tag someone wrong. And that's a typical narrow AI application. And what about machine learning? Sometimes it's like interchangeable for some people, but for my definition, and again, not wrong, not right, machine learning is making computers capable of finding patterns without explicitly programming them to do so. What do I mean about that? If you want to tag a picture to recognize if there is a dog or not in a picture, a cat or not, you can do if and else clauses. If pixel number 32 has red value equals to that, green value is equal to that, and blue value equals to that, and this other pixel, you can do this if you are insane, but you can do it. You can go and like mount this gigantic if and else loops to tag stuff. But if there is a new image that you never saw, it's going to be really, really hard. You would have to update your code for every new image. So we use machine learning models to make this that you just feed data into a model, and this model will learn with more data and more label data in something that it can go like in infinite types of solutions if you try to do with if and else loops. Because that's what we're used to do. Traditional software development is mainly based on if and else loops and functions. And that has a lot to do with debugging stuff, with bugs, with testing, and that has a lot to do with this. When we did algorithm classes or things like that, we are used to do this. You have a decision, have a sequence of commands that will return a value, and depending on that decision, that true or false of that Boolean, you can have more decisions and more decisions. That means that if you build an application in such way, the traditional way, it's easier to debug. And I say easier because debugging is never easy. It involves a lot of console logs and a lot of things, talking to a rubber duck or whatever it suits you, but you do this. And usually, if you find a problem, you find a bug, after a long time sometimes, you can pinpoint, oh, that bug lives on that sequence of code. And you can go there, patch that specific part. On machine learning, it's not that simple. On machine learning, we're not talking about the model, the algorithm on itself. Unless you work for a research department or you work for Uber research or Facebook research or Google research, you're not building algorithms from scratch. You are picking up something like Keras or PyTorch or Theanos or TensorFlow, and to make it similar to people that do not follow this, it's kind of like a Kubernetes manifest. You are specifying kind of like in a YAML file how your network should be, what algorithm are you using, and the data that's going to be input into that, and the algorithm behind, usually write on C++, is going to do that calculation for you in a distributed system. So the two important things are the data that comes into your model and the hyperparameters. Every type of model has different hyperparameters, has different activation functions, and these are the things that machine learning engineers, data science, play around with nowadays when they're building models. But all starts with two things: the business problem that you want to solve and with the data. So starting with the data, usually you go into something that is more like, I don't know if this data is going to be very, very useful, if I'm going to build a model that is going to be really put into production or even relevant. Usually we have a funnel that you have 200 ideas and like 3 or 4 will become a model in production. So sometimes it doesn't make sense to do like your automatic ingestion from day one. Sometimes you just get a CSV file put into an S3 bucket or something like that, and you work into that. And then you start doing your data pipeline. And my data pipeline on this case, I mean, is if you have a CSV file, is exploring that data, trying to find features. You usually go to, data scientists go usually to a Jupyter notebook. They go to that Jupyter notebook, make some graphs, try to find some information that's going to be relevant, and they do feature engineering. For the data points, for the data sources that you find that you have something relevant, then you move on and you do this. You start doing your model development. And you develop that model, again, you have your data already, you now tweak your hyperparameters and the algorithm that you use. I'm going to use ElasticNet. I'm going to use a convolutional neural network with 3 layers. I'm going to use this, I'm going to use that. What are the hyperparameters? What ratio? Each model has different ones. You play around with it, and you train, you test, and tune. You train, you test, and tune. You train, you test, and tune, until you find something that is relevant. This adds value to my business. If you go into that point, my recommendation to everybody is that you stop doing manual ingestion and do automated ingestions. On this point, when you find something that you want to bring into production, automate everything, the algorithm training, but also the data entire pipeline coming from the source. And this is a problem because usually a lot of the data scientists don't do this. They still have CSVs on their local laptops when they want to bring something into production. Because a lot of data scientists think that, okay, now my job is over, I'm going to go to another project. I have my model on my laptop or on my Jupyter notebook. I made a PPT presentation to the CEO. He called a press release, and we are an AI company. Everybody's happy, right? But there's so much to do after that. You have to decide how you're going to package your model, how you're going to deploy your model, how you're going to operate it completely, like how are you going to serve that? Is that a RESTful API that you want to serve? Is an RPC protocol sending something somewhere? How are you going to log this? How are you going to monitor this? Data science don't know this, and they should not know this. They are not unicorns that can do all of this stuff. So one of the important things that has to come here is you start to see some problems. A lot of the data scientists still consider their jobs projects with start date and end date. But what I'm trying to bring to these companies is that this is a product. You're building an API, and that API or that model training or whatever, that is a product per se, and that should contain a product team that will continue to exist. And then it comes my first pain. Nobody wants to be on call. Not even developers want to be on call. I'm a very big advocate that product team should be on call, everybody on that team. We can talk about this later afterwards if you're a developer and you don't agree with it, but that's the only way that I see that developers start writing better production-ready codes. Because when they get the call in the middle of the night at 4 a.m., that's when they start to notice that, okay, the code should be written better, or better tested, or better integrated. Sometimes you cannot fix it because you don't have knowledge. Maybe it's just a DNS problem. You don't know how to solve that. There's a big chance it's a DNS problem, and always have DNS problems. But if that is actually happening, how do we convince these people to be on call? I don't have a silver bullet for this. I wish I did, but this is a problem that I see. The other problem that I see a lot when we're doing machine learning deployment to productions and models is the ethics involved. And the ethics involved is usually you have a lot of biased data. And for what purpose are we building this? Should me as a developer or as a data science be involved in this ethics discussion? I just received a user story. I'm just implementing something. Again, I'm a big advocate that we are the builders, and it's not because someone asked us to do something that we should not think about this. And then again, the explainability problem. If you're building a machine learning model to calculate the percentage that someone is going to default on a mortgage, you have to be able to explain to the person that you denied why it was denied. You cannot just say it was the algorithm, because the algorithm is unpersonal. Nobody contests algorithms. There is a very, very nice book called Weapons of Math Destruction that I recommend people to take a look into this, that really covers how the impersonability of algorithm really brings a lot of damaging for some things. And of course, local development, local data, a lot of real work. And this has a lot to do with, in the majority of the cases that I've seen, data science and machine learning engineers, they come from master backgrounds and PhD backgrounds. These are usually associated with you writing articles that's going to be reviewed by peers in publications, and it has to be perfect. So they only show their model to people. They take out from local development when it's 90% accurate. Sometimes that means that I've seen data scientists that only push to GitHub one time every 3-4 months. Do you think he worked only on that algorithm? No, he tried thousands of algorithms. and you lost all that information when that person leaves the company, because you just have that last commit. So this is a lot of real work that needs to be improved. And the last point that is very problematic when we're doing this is, if you think it's hard to observe a regular software, when we're talking about machine learning applications, it's even harder. Let's go to the hot dog or not hot dog application, the famous one from the Silicon Valley. If you have an application that look at some picture and try to identify if that is food and if that is hot dog or not hot dog, you cannot, after you say this is a hot dog, ask the person, was I right? Can you give me some input if my machine learning model worked or not? You don't have this right or wrong directly from the application. You have to measure by proxies. After I release this feature, do I get more people using my app? If I have a recommendation engine, are the baskets getting bigger or people are spending more money? You have to find proxy measures to validate the efficacy of your model. So, again, all of this stuff, I'm not selling any silver bullet. If I knew how to solve all of this, I would probably be a lot richer and living somewhere else that's warmer. But I'm talking here about culture change, about finding new ways of working. And this is extremely similar to the problem that I described in the beginning, into the DevOps thing of the culture change. And this is the thing that I tell people that, again, it's just like saying, eat better, make more exercise. Change the culture is like, yeah, change to what? Change who? Change when? The only thing that I try to tell people and that I like about the Dutch culture is be candid, be direct, and involve other people on the decision process. Involve the machine learning, involve the data science. Think as a product team. Think that your goal as a developer, as an IT manager, as a developer, as an IT manager, as a PO, as whatever, what is the goal? Do you work for a stichting? Then you have a specific goal. But the majority of us, I think we work for profit companies, so our goals is not to write code, it's not to manage people, it's to make more money for the company. So what I tell people is this: instead of just product and development talking with IT ops and stuff, no. Machine learning engineers, data science, now deep learning engineers, data engineers, whatever name comes now, these people should work together in products. And the thing that I tell all the data science, and I hope that you tell them at your companies as well, local data science is that. You cannot develop machine learning models with algorithms running on your laptop or using CSV files that you downloaded or make a SQL query from a data warehouse and then putting on your laptop. No. There are tools nowadays that allow better collaboration with these models. Oh, and of course, Taco talked today about CI/CD. I know Taco for a few years, and we had a lot of discussions about CD for machine learning already. It's not easy, but it's feasible. But every model that someone builds, even if it's 20% accurate, you don't need to bring that into production, but it needs to be on a deployable state. If you ever decide as a business decision that should go into production, it should not take months, as I've seen companies that have a model, but it takes 12 months to bring that into production. And more than CI/CD, we should have continuous evaluation. If you're testing new algorithms, new hyperparameters, new data sources, you need to be able to compare these models and these runs amongst themselves and make that transparent for everybody. And the bugs again. Like I said, you cannot pinpoint where the bug in a machine learning model is. Like, if I have the hot dog or not hot dog thing, and I know that this here is not a hot dog, but my cell phone tells me it is a hot dog, I cannot fix this model for just this case. I have to retrain my entire model, and this may cause errors on other things. I cannot pinpoint specific points on the machine learning that will just make this picture correct. And this is a different way of thinking. So machine learning bugs are more related to these three things. The first one, bias. And bias usually comes from the data, not from the models. And the biggest example from this last 6 months is the Amazon sexist hiring algorithm. Amazon was filtering CVs in automatic fashion for their positions, and after a few weeks, they realized that the majority of the CVs being forwarded for the interviews are from male engineers. And when they start to look into it, they realized that it was because the data that they had was majorly made by male engineers. And the most amazing thing, gender was not part of the data set. So the algorithm on itself was identifying gender based on other proxy metrics that you find. But still, this was a big screw up from Amazon because there are a bunch of ways of detecting this before bringing it into production. But it happened, and bias is very preoccupied. The other two things, they are really bad in some sense because you cannot find these bugs before you bring your model to production. What I mean, drift happens when your model has 90% accuracy. After 1 week, it gets 91% accuracy and gets 92, and then it starts to decrease the accuracy of the model. Why does it usually happen? Because people start to interact with the model, and that starts to influence their behavior, and your model needs to be adjusted, needs to be fine-tuned, needs to be calibrated. Otherwise, it will drift away. And this is very counterintuitive to what we consider machine learning. A lot of people think if we just add more data, it will become better. No. If your model is influencing the data, it can go the other way around. You can drift from what you wanted. And the third one, the fragility, is also something that happens within time. That means that if, for example, your model has GDP per capita as one of the data points, and Trump decides all of a sudden that the GDP of the US is going to be calculated in a different fashion, so how is that new value going to be affecting your model? How fragile your model is to different data inputs? Or let's go to a more local case. You have the price including VAT, and that's an important thing on your model. VAT rises all of a sudden in 1 month. How is that going to influence your model? Should you take out VAT and recalculate for your historic series, whatever? But these things will only happen, drift and fragility, after you are in production. And that comes to the point that the life of the data science does not end when the model is ready, because these things will happen. You will find bias that you didn't thought about, model will drift, and will be more fragile to changes, and you have to observe how your model is in production. So the problems that I see that data science face nowadays are some, like they have problems with collaboration, and again, this is related to the culture part, that they are more master students, PhD graduates. They don't use proper versioning of code and data for the majority of the time because it's not part of their culture, because they don't know, because it's hard, but they don't do this. They don't know how to properly evaluate amongst their models. They don't understand how to package their models, how to deploy, how to serve their models. So I like to point out some tools to help, all open source tools. Spark since 2.3, so 10 months now, it can run on top of Kubernetes. So if you have a Kubernetes cluster and you don't want to set up a Yarn, a Hadoop cluster or something like that, run on top of Kubernetes. Oh, sorry. Docker can be run now on Hadoop Yarn since 3.1, so it's been 7 months now. So if you are in an on-premise company that has a big Hadoop cluster, now you can tell your data science, hey, you can run Docker containers now. Do you know that? The biggest problem with this one is you have to figure out all the internal networking part that Kubernetes has already sorted out. Kubeflow, on the other hand, is a nice project that gives extension of the Kubernetes of the kubelet API on top of the Kubernetes that lets you use TensorFlow serving, Jupyter Hub, and other things inside Kubernetes on itself. MLflow is the tool that I'm going to demo, so I'll leave it for afterwards. And the AWS SageMaker build is a CI/CD pipeline, so it's just a bunch of CloudFormation scripts when you're using AWS SageMaker to build your machine learning models. So you just need to copy some things here and there, put your keys, and you have your CI/CD pipeline for a SageMaker build. So let's go for the MLflow demo. See it here? That's here. Something is open, yes. So, this is a simple model that a data science could have made. This one is related to wine. So, who likes wine? I have some data points here on this wine quality SV that has like the value of citric acid, sugar, blah, blah, blah. And in the end, the quality of the wine made by some sommeliers kind of stuff. So I want to build a model that will, based on these characteristics, predict the quality of the wine. So I built this simple model using scikit-learn that gets my wine data, split into a training and a testing set, set up what do I want to predict. I want to predict the quality. And I'm going to use an elastic net model that has 2 hyperparameters. Don't need to understand all of this if you're not a data scientist, just want to give an example. And you have to define the metrics that you want to calculate this. And I want to compare this as 2 metrics, R², medium average, and something like that. And the only thing that a data science needs to add to use MLflow here is this. Import MLflow, and the tool that you're using, in my case, scikit-learn. And then, before you run the model, do this with MLflow start run. That's it. And in the end, you need to log. I need to log my parameters, I need to log my metrics, and I want to log my model. Why do I do this? I can show you. This can be run on a server. This one is running on AWS, and I'm proxying here to my machine. So it's going to be on the localhost 5000. So what this is showing me is that experiment, on this case default, but you can have different experiments here, was run by this user with this source, this version here. You can add the git hash for it. And you can see this person run this at this time with this parameter on this metric. So if we run this now, let's say a number, 0.28, another number, 0.57. Gets me all the metrics, and if I refresh this, this is sending to an S3 bucket, and I have here that it run at 433 with the alpha and the ratio that is set. Then I can start comparing models. Hey, let's see how all my models are. Comparing the value of the L1 ratio and the R². Okay, so clearly you start to see like that there is a pattern here that maybe my minimum would be around here, but I want my R² to be higher, so probably need to be something around here or here, so I can do some more runs and start to compare them. By doing this, I can give some flexibility because this is a server running. Other people can log in into this. You can have different users, different things, and you can start like to have a history of all the things that you trained. Even if your model sucks, you can compare them. And this solves my problem for collaboration, for continuous evaluation, but it can also solve my problem for data versioning, because I can add my parameter as, for example, a data on an S3 bucket. I can like pinpoint, hey, for this model, I use this data on this S3 bucket, and then if someone wants to recreate that parameter and that metric, he just needs to point that to that specific file on that S3 bucket. So you can start like making rerunnable things, even if your data science get hit by a bus or something. You have no loss in your company. You're not depending on a person anymore. But we still have 3 things: packaging, deploying, and serving. And this is also taken care of by this tool. How? This run. Can everybody read that, or should I make it bigger? Make it bigger. MLflow is already integrated with some things like scikit-learn, TensorFlow, Keras, PyTorch. And if I do, for example, MLflow scikit-learn serve, that ML runs, it's going to be something that is inside my S3 bucket on the folder ML runs, and that is a hash of the run. And you have an artifact model and I'm forwarding that to the port 1235 of my localhost. So if I start serving that, now I have a RESTful API running on this case is running on a Kubernetes cluster, and I'm forwarding to my local port. I can curl to my local port and send it to them. So if I do this now, I get a prediction just using a curl, so I can start to scale on my model. So now I have my model serving here. So I package, I deploy, and I have it serving here in an easier fashion. So, oh, no, wrong tool. So what I wanted to show with this demo is that the collaboration part is not solved by any tool. That is more like a culture change. And that culture change I borrow from the DevOps movement because, like I said, DevOps to me is not about Ansible or Kubernetes or automation. DevOps for me is about bringing an idea into production and monitoring and observing as soon as possible. Versioning code and data, you should use Git for the code, and for the data, if you are on the cloud, use the blob storages from Azure or the Google storage or the S3 bucket. But if you are locally, there is this one tool that I really like. It's also open source called Pachyderm, and it's a data versioning tool that is built on top of Go that is really, really, really a nice tool. And for the other things, I am now using a lot of MLflow. I work it with a lot. It's built from the Databricks people, the same people that built Spark. It's completely open source. Version 1.0 is going to be released now in end of January. But there are other tools that can do this. I'm still waiting for Uber's to release their Michelangelo, their MLflow own thing. But we have other solutions for this. So with that in mind, I would like to open up for questions. I think we have quite some time. And as a latest plug, yeah, we are hiring, so come on.
Big round of applause for Thiago.
Do we have some questions, Darth Vader?
Nobody has questions. Everybody wants to go home.
Oh, we have a question over here.
I'm the only person in the middle of they going home and staying here, so.
No, I don't think so. I was a little bit confused about the coding.
Can happen, can happen.
Who understood the coding? Yeah, you? Okay. Yeah? Ah, cool.
Well,
no questions? Yeah, over there. Oh, no? Ah, that was your classes. Okay. Thank you very much. Big round of applause.
Thank you.
Woo! Thank you very much. Present over here. Okay. We got a little bit time, so I think there's refreshments over there.